Okay, we'll dive in here. Our content today involves circles and composite figures. We're going to start out talking about circles. And while you're probably pretty comfortable with what a circle is, I do want to give you a formal definition. A circle is all the points that are the same distance from a single point. And that sounds a little strange. So I have this single point right here. A circle is all the points that are the same distance from that point. When you draw circles, they don't have to be perfect. But so all the points that are the same distance from that single point. That single point we'll call the center of our circle. And then there's some anatomy of a circle I want to make sure you're comfortable with. If we draw a line that goes all the way through the circle, it goes through the center and it goes from one side to the other. Does anybody remember what that's called? It's okay if you don't, but somebody might. What's that one called? All the way across the circle, goes through the center. What would we call that line right there? And like I said, it's okay if you don't remember, but if you do, it's a chance for you to share that with us a little bit. I want you to sort of think about it. You may have had a geometry class somewhere along the line where you talked about, you know, the components of a circle, different things that are associated with a circle. That red line there all the way across. Yeah, very good, Kevin. Outstanding. And I think Nicole's going down the same road there. We'll see. But yeah, that's the diameter. And it's all the way across the circle from one side to the other that goes through the center. And we'll use D as an abbreviation for diameter. Makes sense. And then there's another piece of a circle that's really important for us. Yeah, you're right, Nicole. It was diameter. You had it all the time, the whole time. And that's if we go from the center to the circle. Anybody know what that's called? If we go from the center to the circle. I think you could probably be confident on this one, Nicole, but we'll see. I understand that. Sometimes our technology fights with us. Anybody know what it's called when you go from here to the circle? Anybody know what that line would be called? There's really only a couple words associated with the circle. And so there's a pretty good chance that the one you're thinking of is this one. I'll give you I'll give you a little bit of time, but if nobody comes up with it, it's all right. I will tell you. I won't leave you out there. Yes, very good, Jenny, Dulcie, you're exactly right. That one is the radius. And we'll use R as our abbreviation for the radius. So a circle, you know, unlike a rectangle that had length and width, a circle has a diameter and it has a radius. One thing that I want you to notice here about this is if we look at the diameter and the radius, what we can see there is, well, this would be a radius and this would be a radius. So the diameter is always going to be 2 times the radius. So if we know the radius, we could just double it to find the diameter. And if we know the diameter, we could cut it in half to find the radius. So it's easy to go back and forth between those two. That's pretty much the anatomy of a circle. When we looked at different shapes like rectangles, parallelograms, trapezoids, triangles, we were concerned with finding perimeter and area. With a circle, we're not going to find the perimeter of a circle. And the reason for that is perimeter is when we add up all the lines that are used to make the figure. Well, there aren't any lines in a circle. Instead, there's no straight lines in there. There's no line segments. There's nothing that's a straight line anywhere. So instead of talking about perimeter for a circle, we'll talk about circumference. And the circumference of a circle is how far you would go if you were standing there and you walked all the way around the circle. It's the distance around the circle. That's going to be called circumference. there's going to be a formula for the circumference of a circle. And what's involved with the circumference is a number that is really significant. The ancient Greeks were very familiar with this number, and what happened there was they would take the circumference of a circle, the distance around the circle, and divide it by the diameter of the circle, which, well, we know what the diameter is. And no matter what the circle was, a little bitty circle like this one, big giant circle like that one, if they took the circumference and divided by diameter, circumference divided by diameter, they always got the same result. And that result was the number 3.1415926, and that keeps going. Anybody know what we call that number? Excellent, Ashley, very good. And you spelled it right. That's really good too. Ashley's exactly right. We call that number pi. It's a Greek letter, pi, the Greek letter. It looks like this, pi, the Greek letter. And essentially what that is the Greeks were so fascinated by the idea that no matter what circle they used, if they did circumference divided by diameter, every single time it was the same thing. Well, that was so remarkable to them that they gave it a name, and the name that they gave it was pi. When we go to find the circumference of a circle, we're going to use this idea down here to get there. You don't have to write this yet. I just kind of want to show you something real quick, and then we'll finalize our formula. But since circumference over diameter is always going to equal pi, if we wanted this formula to be about the circumference, what we could do is we can multiply by diameter on the left, multiply by diameter on the right. Those will cancel. And now what we can see is we've got that c by itself, and that's pi times d. And that's going to be our formula for the circumference of a circle. Pi multiplied by the diameter. Something that we saw just a few minutes ago is that diameter is the same thing as 2 times the radius. So instead of pi times d, we have an alternate formula that we can choose which one we want to use. Since circumference is pi times diameter, we could write that instead of pi times diameter, we could write that as pi multiplied by, let's see, the diameter is the same as 2 times the radius. So the circumference would be pi times 2 times the radius. That's a little bit clumsy. So instead of this way, we could also say circumference is 2 times pi times r. And so we have 2 different formulas that we can choose from. Depending on the problem, we might want to use this formula. Circumference is pi times diameter. Or we might want to use this formula. Circumference is 2 times the radius, 2 times pi times the radius. So depending on what we know and what we don't know, we can use either one of those formulas to find the circumference of a circle. Excellent question, Jenny. That's fantastic. So as we look over here at pi, we can see that it's 3.1415926. And, you know, Tuesday, when we were talking about our trigonometry functions, we kept all the decimals. Well, pi is going to be a little different than that. When we have problems involving pi, you're going to be given instructions just to use pi as 3.14. And so when we're solving problems, we're going to use 3.14 for pi. It's an important thing for me to mention because you'll see that in the instructions for the problem. It'll say use 3.14 equals pi. A little bit of danger in there, and danger is probably the wrong word, but one word of caution. Your calculator probably has a pi button on it. You may have an instinct to use that pi button. The thing is, if you use that pi button, then it's using all these decimals. And instead, we want to use 3.14 for pi. If you keep all the decimals, your answer might be off slightly from what Canvas is going to show as the correct answer. So I want to encourage you, remind you, anytime you see pi in a problem, we're going to use 3.14 for pi. The problem should have that in the instructions, the directions for the problem. But we're going to use 3.14, and basically that way we're all getting the same answer. If half of us are using the pi button and half of us are using 3.14, then our answer is going to be off by a tiny little bit, and that'd be frustrating. If we all just use 3.14, then we'll all get the same answer. Another thing that I need to mention here is area. All we've talked about so far is circumference. We have two different formulas that we can use for circumference, but we also have a formula for area of a circle. And that formula for the area of the circle is pi times the radius squared. So that's going to be our formula for the area of a circle. So we get to choose whether or not we want to use pi times diameter or 2 times pi times r for the circumference. As far as area goes, we only get one choice, and it's this one here. Our formula for the area of a circle is pi times the radius squared. Any questions on those before I have you try finding circumference and area of a circle? Fantastic. Let's do it. All right. Find the circumference and area of a circle with a radius of 5 centimeters. And remember, use 3.14 to equal pi. I'm going to set up a poll for this and give you a chance to try it. We're looking for the circumference and the area of a circle with a radius, 5 centimeters. The circumference is listed first, the area is listed second. Find the circumference and area of that circle with the radius 5 centimeters. You can see they've all been rounded to the nearest tenth, so you can pick the one that matches your work. And then if what you come up with for circumference and area is not shown there, pick the one that's closest. That way I'll know you've had enough time to do it. Essentially, this one's about using the two formulas, formula for circumference, formula for area. Definitely the type of question you can expect to see on homework, quiz, and probably exam, given that circumference and area of a circle is a pretty important idea, one of our more basic important ideas. Let's go another 30 seconds on this, and then we'll talk about it. All right, let's take a look and see where we are. Okay, not unanimous, but strong agreement down there on 31.4 and 78.5. Let's take a look at this one and make sure we're calculating this thing correctly. If you see anything you're not sure of, you're not sure where the numbers came from or why they got put there, please make sure you ask me. So the first thing we're going to find here is the circumference. And we know circumference can be found either of two ways, pi times diameter or 2 times pi times the radius. Well, in this particular problem, I was given the radius, so I'll go ahead and use this one. If you wanted to, you could use double that radius to find the diameter and use the other formula, but since they gave me the radius, I'm just going to use this formula here. And so my circumference will be 2 times pi, which I was told to use 3.14, times the radius, which is 5 centimeters. I just need to multiply those together. And so we'll do that. We'll have 2 times 3.14 times 5 and end up with the circumference is 31.4. Units won't be an extremely important part of your homework quiz and exam, but just so we can discuss them, this would be 31.4 centimeters. This is a distance that can be walked. So it's similar to perimeter, and it's the fence that would go around the circle. So it's just a straight line distance, 31.4 centimeters. Now we'll look at the area. For area, the only formula we can use is pi r squared. You do have to be a little bit careful here, and I probably should have mentioned this. Remember order of operations, which is please excuse my dear Aunt Sally. And here we have multiplication and we have an exponent. And exponents come before multiplication. So we're going to do radius squared first, and after that we're going to multiply by pi. That's an easy mistake to make here. You just kind of go left to right, but because exponents come before multiplication, we're going to do the squaring first and then multiply after. Let's go ahead and take a look at this one then. Our area is going to be pi multiplied by the radius squared. You might be thinking, well, hey, I thought parentheses came first, and that would be a perfectly reasonable thing to think. That's only if there's work to do inside the parentheses. What I've done here is write these parentheses down just to sort of help me keep things organized. It'd be okay if I wrote 3.14 times the radius squared. It would mean the exact same thing. But the parentheses just sort of help things stay organized. There's no symbol in here, so I know it means multiplication. And so I'll use parentheses like that often. They just help things stay organized and separate from each other. But there's no work to do inside these parentheses, so there's nothing for us to do first. Instead, we look and we see, okay, I've got multiplication, I've got an exponent. The exponent has to get done first. And so we'll do the exponent first, and then we'll have area is 3.14 times 5 squared. 5 times 5, that's 25. And so we'll multiply 3.14 times 25 and get an area of 78.5. This one's area. So I've got this circle over here with a radius of 5 centimeters, and what we're finding is the area. How much space does it cover? So this is more like carpeting. How much space does it cover? Since it's area, we would have square centimeters, 2 dimensions. So area would be 78.5 square centimeters. One of my favorite questions that comes up sometimes is, how's it square centimeters inside a circle? It's a very good question. But if we were to chop this up into centimeters, how many squares are there in there? Well, we can count the squares. And then we have fractions of a square that when added to another fraction of a square would eventually get us to 78.5 square centimeters. Any questions on what we did there to find the circumference and area of a circle? Fantastic. Okay. Here's a question for us. If the circumference of a circle is 28 inches, what is the diameter? Use pi equals 3.14 and round your answer to the nearest tenth. I'm not going to do a poll for this one. We're just going to work through it together. You don't have to draw a picture, but after doing all that trigonometry on Tuesday, it might be a just sort of a natural reaction for you to draw a circle. And so I've got this circle here, and what I know about this circle is that the circumference is 28 inches. And what I want to know is, what is the diameter? Well, let's see. I have a couple formulas for the circumference of a circle. Circumference is pi multiplied by diameter. Circumference is also 2 times pi times the radius. Those are both excellent formulas. I can use whichever one I want. In this particular case, said the circumference is 28. What is the diameter? Well, I'm being asked for the diameter, so I'm going to use the formula that has diameter in it. And let's see here. I was told that the circumference is 28. Okay, 28 is, use 3.14 for pi times d. Oh, so 28 equals 3.14 times d. I'm trying to solve for diameter. I need to find out what that d would be equal to. What do I have to do here to get d by itself? To get diameter by itself, what do I need to do here? What's the step I need to take? And I know most of you know this, but we don't do that much algebra in here, so it's kind of nice to talk about it a little bit when it does come up. Perfect. Erica, Jessica, you're both exactly right. We're going to divide by 3.14 on the right so that those will cancel, leaving just that d for diameter. And if we divide by 3.14 on the right, we also have to divide by 3.14 on the left. What we end up with then is just diameter on the right-hand side, and then 28 divided by 3.14 on the left is going to be 8.91719, and that keeps going. I was told in this particular problem to round to the nearest tenth. So we need to identify the tenths place. Look one space to the right, that's 4 or lower, so we're going to round this down to 8.9. Since it's diameter, it's a straight line distance, it would be inches, although you'd just be asked for the 8.9. Essentially, what we did there is we used the formula for circumference, but instead of finding circumference, this time we found the diameter. Are there any questions about anything we've done so far? Because that's our coverage of circles. We're going to move on into composite figures next, but I want to make sure we're comfortable with everything related to circles before we go forward. Very good, Matthew. That's awesome. All right, composite figures. What I'll tell you about composite figures, just to sort of give you a heads up, many of these are going to be pretty straightforward and relatively simple, but there will be the occasional one that is a little more challenging. So that's how composite figures are going to work for us. What we're looking at here is sort of an L on its side, I guess. And if I wanted to find the circumference and area, circumference, sorry about that, perimeter and area, had circles on my brain, I guess. If we wanted to find the perimeter and the area of this figure, I don't have a formula for that. I've got a formula when it's a rectangle, a parallelogram, a rhombus, a square, trapezoid, triangle, but I don't have a formula for the perimeter and area of an L shape. What am I going to have to do to find the perimeter and area here? For perimeter, your instinct is right. I'm going to add up all the sides. What am I going to do to find the area? Because I don't have the formula for the area of an L shape. How am I going to find the area of this thing? And there's a couple of different ways you can go, but one is more common than the others. But if I want to find the area of that L shape, what am I going to do? How much carpet would I have to buy for this weird L-shaped room? You know, that's what we want to know here. How much space is taken up by this L shape? And I'm not expecting you to tell me what the area is. I just want you to tell me what I'm going to need to do. You know, with like a lot of our problems, we can't see what the answer is right away. There's going to be a process, and we've got to, you know, go through that process to get to the other side where our answer is. But we need to kind of think about what is the right way to approach this problem? What's the right way to attack it in a lot of cases? And this is that kind of thing. Like, you know, how am I even going to get started? We will do perimeter first, although there's a little bit of an issue with finding the perimeter here. We'll talk about area in a few minutes then. So, and if you want to tell me how I'm going to find the area, that's great. You go ahead and do that. I understand it can take a little while to type something. But for perimeter, I'm going to imagine myself standing here and walking around this figure. And I just need to add all that up. The problem is, when I go to start adding these up, I'm missing some numbers. I've got a 2 and a 3 and a uh-oh, and a 4 and a 10 and a uh-oh. I don't know what those are. So I would love to find the perimeter of this figure. But if I'm going to find the perimeter of this figure, I'm going to need to know how long this side is right here. And I'm going to need to know how long this side is right here. All right, while we're on the topic of perimeter, anybody have an idea how long this side is? And how did you get it? How long is that side right there? Very good, Kevin. That's excellent. And how'd you get it? What'd you do? I'm curious. And anybody else can fire away. If you had that 8 also, you can type in how you got it. 10 minus 2. Perfect. If I look at the horizontal lines in this figure, I can see that from all the way on the left to all the way on the right is a length of 10. If this much right here is 2, then I can sort of imagine that line being right here and that being 2. And so in order to make up the rest of the distance, that one must be 8. And so by using subtraction there, we can find out that the length of that piece is 8. All right. Well, what about this one over here? How long is that one? Miranda says 7. All right. How'd you get that 7? And it could be Cabron, it could be Cameron. You can let me know how to pronounce that correctly. You know, I don't want to do it wrong. You can do it email, you can do it in here. Either way, it's fine with me. Miranda, you said 7. How'd you get 7? Perfect. So in the same idea, we look at our shape here and we go, well, this is all the way to the top to all the way to the bottom. And I look at these vertical lines that I've got. Those are all verticals. And if I take this 4 and I sort of imagine it being right there, and I got this 4 plus this 3, sure enough, that makes 7. And that's perfect. That's exactly right. That's exactly how I'd want you to go about it to find out that this one was 7. Now I know all the sides of the figure. I can find the perimeter. We're just going to add them up. And let's see. So our perimeter here is going to be 2 plus 3 plus 8 plus 4 plus 10 plus 7. I just need to add all those together. So let's see, 2 plus 3 plus 8 plus 4 plus 10 plus 7. We'll add those together. 2 plus 3 plus 8 plus 4 plus 10 plus 7 is 34. My perimeter here is 34. I don't know what the units are. They could be feet, miles, yards, centimeters. I don't know. But I do know that the perimeter is 34. We needed that 8 and that 7 to find the area anyway. Anybody got an idea what I'm going to do here to find the area of this? How am I going to find the area of this L shape? Because I don't have a formula for that. And some of you that are very visual people probably see this right away and it's not that complicated. That's very good. I'm going to ask you to type it in there so that I know that you know what we should do next. Excellent, Jessica. That's it. You're exactly right. We're going to break it into two shapes. We're going to cut this into two shapes. And some of you might see this and think, well, I've got a rectangle here and a rectangle here. I'll find the area of each of those rectangles and add them together, and that'll be the area of the whole shape. And that's exactly the idea. We're going to break it into smaller pieces, find the area of those, and that'll give us the area of the whole thing. It's certainly, and it's perfectly fine if this is what you see here when you see breaking this into two shapes. That's not how I see it. I would see it as this little guy up here and then this big rectangle down here would be the two that I would see. But either way is okay. There's not a right way and a wrong way to break this into smaller shapes. So if you cut it into this rectangle and this rectangle, you're going to get the same exact answer as if you cut it into this rectangle and this rectangle. So there's not a right or a wrong way to cut it, as long as you're taking the entire shape, cutting it into pieces, find the area of each one, and then add those together. So let's start with this rectangle over here in the top left corner. We do have to be a little bit careful here when we go to find the area of that rectangle. We want to make sure we're using the right numbers, because it could be really easy to look at this and go, okay, well, it's 2 by 7, so the area is 14. Well, hold on a minute now. I would agree with you on the 2, but the height of this is 3, not the 7. 7 doesn't play a role here at all. This rectangle is 2 by 3, so we multiply those together and find out the area is 6. Now we're going to find the area of that other rectangle that we created. The other rectangle, let's see, the length is all the way from left to right, so that's this 10 down here. And the width is 4. You have to be careful. It'd be really easy to make a mistake and use this 7 or use this 8, but we don't want to do that. The length of this rectangle is 10. The width of this rectangle is 4, so we'll multiply those together and get that its area is 40. And then so the area of the whole shape, the area of the entire shape is what we get when we add those together. 6 plus the 40 is 46. If you cut it the other way, you'll see that you get the exact same area as an answer. You won't get the 6 or the 40 because the rectangles are a little bit different sizes than these, but you should still get the 46. Are there any questions on this before I have you try one? Excellent. All right. Here goes. All right, so you'll notice we have missing side lengths. We're going to have to find this one and we're going to have to find this one before we can do anything. I'm confident you can do that. I want you to find the perimeter and area of this composite figure. I'll set up a poll for it and give you a chance to tell me. Take your time, practice this one. Definitely the type of question you can expect to see on a homework, a quiz, or an exam. So take this opportunity to practice it. If you're able to get this correct now, then you can feel pretty good about when you go to do homework and quizzes. If you struggle with it now, that's okay, it's brand new. You can ask questions right here in class. That's perfect. if you get an answer that's none of the ones listed, pick the one that's closest to yours, just so I know you've had enough time to work on the problem. I'll give you a little time on this. There's a little bit to do here. So take your time, find the perimeter and area of that figure. So quite a few things to do here. We need to find the missing side links. Once we know those, then we're just adding them up to get perimeter. So that's not very complex. But then how we decide to cut this up and then finding the area of the smaller rectangles and adding them together to give us the area of the whole shape is a little bit more involved. So we will take a look at this together. Let's go another, I don't know, 20 seconds and then take a look at it. If you need more time, let me know. All right, let's see where we are on this one. Okay, fairly strong agreement. Definitely strong agreement on 52 as the perimeter, which is great. And then a little bit of disagreement on the area. So we'll take a look at that one very carefully. So let's go through it. First thing we want to find is the perimeter. And if we're going to find the perimeter, we're going to need to know these three missing side lengths. nice thing about this shape is two of them are pretty easy to get. This is 7, so this one over here is also going to be 7. And this one's 3, so this one over here is also going to be 3. Those were relatively simple to come up with. Now, we still need this one right here. And let's see, if all the way from left to right is 16, and I've got 4 right here and 1 right here, okay, so that's 16 all the way from left to right. This is 4 and this is 1, so that's 5 of it. So that leaves 11 more. One of the things that'll be true throughout the geometry chapter really is, if you're looking at this going, how in the world could that be 11? It doesn't look big enough. You know, it's kind of the same length as the 4. Well, the markings override what the figure looks like. So if the math says this is 11, then it is. Don't look at the picture and say, well, it can't be 11 because it's too close to this. Don't let that get in your way. Our pictures are just a sketch. They're not meant to be precise. So if the math says it's 11, then it's 11. Okay, now we need the perimeter of this, and we're going to have to add up all those sides. You could start anywhere. I tend to put myself at the top left and imagine myself walking around. And let's see, that's 4 plus 3 plus 11 plus 3 plus 1 plus 7 plus 16 plus 7. With that many numbers, one thing that I'll do is I'll just take a minute and go 1, 2, 3, 4, 5, 6, 7, 8. So I better have 8 numbers in my calculation. 1, 2, 3, 4, 5, 6, 7, 8. Okay. It doesn't guarantee that I wrote down the right numbers, but at least I didn't miss any. So now we'll add that up. 4 plus 3 plus 11 plus 3 plus 1 plus 7 plus 16 plus 7. And it looks like the perimeter here is 52. And that was by far the most common response, so that's excellent. If you have questions about how we found that perimeter, make sure you ask them. Okay. Now we need to find the area. And just right away, you could cut this with a vertical rectangle here and a vertical rectangle here, and then this rectangle here in the middle. Perfectly fine. You can find the area of those 3 rectangles, add them up, and get the area of the whole shape. My guess is that most people probably cut it up this way. It's okay if you did it the other way. Both ways work. Long as you cover all the area that's inside there, either way is just fine. All right. So I need to add up the areas of these 3 rectangles. I'm going to start over here and this one in the top left. And when I get the area of that, I've got to be a little bit careful to make sure I use the proper side lengths. This one's clearly the 4, and then I have this vertical here. It's not the 7, it's the 3. So the area of that rectangle, length times width, is going to be 12. If you see something you're not sure where it came from, you're not sure why I did it that way, please just ask. Oh, perfect, Nicole. That's awesome. And right, if you can see your mistakes, that's a huge step in the right direction. Like, it's one thing for me to see something you've done and go, here's where your mistake is. There's value in that. But when you see your own mistake, then it's tremendous. And then over here, if we have this rectangle, we have 1 times 3. Don't use that 7 because that's not one of the sides of the rectangle, and so that has an area of 3. And then finally, we have this big rectangle down here, and there'd be an instinct to want to call that 16 by 11 because there's a 16 down here and 11 right here. So makes perfect sense, 16 by 11, but hold on a minute. The 16, sure enough, that's the length, but the width of this rectangle, boy, kind of want to use that 7, but the 7 is all the way from the top to the bottom, and that's not where this rectangle goes. This rectangle only goes up to here. So I need to figure out the height of that rectangle. And so what I'm going to have to do then is, since it's 7 all the way from bottom to top, and it's 3 here, then this piece must be 4. And basically, I'm just looking at the vertical lines when I'm doing that. Anytime I'm doing addition or subtraction like that, I'm looking at the vertical lines and then I'm looking at the horizontal lines, depending on what it is that I need to find. And then if this is 16 by 4, we'll multiply those together and get 64. That's the area of that rectangle. And so the area of this entire shape is going to be the 12 plus the 3 plus the 64. And that's 79. A couple of things I'll say here before we go forward into another one is if anybody has any questions you want to ask about what we did, let me know. If anybody wants to see it done with the rectangles drawn this way, let me know. I'm perfectly happy to do that and convince you that it comes out to be 79 also. And then there is one other way you can go about this. You might be typing it in for us, I'm not sure. But there is one other way you can go that you might decide you like. There it is. What Hugh did here is this. He said, okay, I am going to look at this shape and I am going to pretend that there is one big rectangle that is the whole thing. I'm going to find this rectangle and subtract it. It's an advanced approach, but it's pretty clever and I like it very much. Okay, so there's this whole rectangle that would be all of this. And then if I subtract what's in there, I get what's left. And that's exactly what Hugh did. It says, okay, so 7 by 16 gives me the big rectangle. And then this 3 by 11 gives me the 33 that's in this little rectangle. And I'll subtract. Excellent. Excellent. Any of those approaches is just fine. Let me know if you have any questions about that before we look at another one. All right. Okay. You might be thinking, what's the big deal? It's a rectangles just like the other ones. We're going to chop this up and we'll find the area. And you're not entirely wrong. But there is one little piece of this that I think is challenging, and I want to make sure you see it before I turn you loose to work on problems from the book or the homework or the quiz. If we want the perimeter and area of this figure, to find the perimeter, we're going to need to add up all the sides, and we don't know this one, and we don't know this one. That horizontal line that's in there, that's not going to be very hard for us to find. It's 12 all the way across the bottom. This is 4, and this is 4. So those two together make 8. I need it to make 12 all the way across. So that one's going to have a length of 4. However, this one over here, not quite so simple. I want you to take a minute and see if you can figure out the length of that side. Let me know what you came up with and how you came up with it. Because I think it's pretty challenging to come up with that one. Maybe I'm wrong. Maybe you're like, well, obviously it's this. Great. Those of you that are really visual probably see this right away. If any of you's like an art major, you're like, yeah, obviously. But I do want you to just try to figure that one out. Okay. We've got a suggestion for 1. And it's okay, throw them out there. You know, I want to hear what you come up with and how you came up with it. And you don't have to agree with each other. Nobody's, you know, there's no judgment here. We're just taking a shot to see how long that side is. And how you came up with it. That part I want to know. Because, you know, I don't want it to just be a guess. I do want it to be based on some sort of reasoning, right? It's a vertical line. So we know that the vertical lines in the shape are going to have something to do with it, with how we come up with that number. And hopefully everybody's comfortable finding that that horizontal line has a length of 4. This particular vertical line, a little more challenging though. And I'm curious to see what you come up with. And it may be that that 1 is correct and that's our only guess and that's it. But I'm curious to see what else you might throw out there. Difference between the two sides is 1. Okay, there's something to that. And I think what Nicole is saying there is, if we look at all the way from bottom to top over here and all the way from bottom to top over here, the difference is 1. I would agree with that. What that does for me then is, if I sort of imagine this being, okay, well, here's where that 7 goes. Oops. Uh-oh. Okay, so here's where that 7 goes to. So when I look at my shape, that 7 would be at a height that is, see, if I go straight across, that would be right here. So from here to the bottom would be 7. Let me know if you agree or disagree with that. Hopefully you, let me know if you disagree, that from here to the bottom would be 7. And since it's 8 all the way from top to bottom and 7 all the way from here, what that tells me is this little piece right here is 1. So not that obvious at first glance, but essentially what I've got is, if it's 8 all the way from top to bottom and 7 from here, then I know that just right here is 1. Pen got goofy on me, is 1. And then if I look at this as being 2, then this is also going to be 2. And so altogether, what Nicole said for us there is, altogether then, it's this 1 plus this 2 makes that side length have a length of 3. I think this one's pretty hard to see. And I'm going to walk back through that one more time. So what we did there, oh, Ariana did see it first. Thanks, Nicole. I missed that one. Great, Ariana. That's excellent. Very good. That if all the way from top to bottom is 8 and this much is 7, then that means that that little slice right there is 1. And then if this is 2, then this is also going to be 2. And so what that means is this whole line altogether then is 3. And so I think when Cabran said 1, he was talking about that difference between these two, which was a really important part of our process to get there. And then Ariana took it one step further and made it the 3. And Nicole agreed. So that's perfect. Now we've got all of our numbers. Now we can find the perimeter and area of this figure. So we'll go ahead and do that just to sort of finish it off. The key to this one, though, was this was a hard side length to find, and I wanted to make sure that you saw that done before with sometime in class today. All right, so our perimeter here, I'm going to put myself there, is going to be 4 plus 3 plus 4 plus 2 plus 4 plus 7 plus 12 plus 8. Just to double check, that's 1, 2, 3, 4, 5, 6, 7, 8 numbers. Make sure I have 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8 numbers. All right, now we'll add those up. 4 plus 3 plus 4 plus 2 plus 4 plus 7 plus 12 plus 8. Looks like 44 will be the perimeter of this figure. And again, we don't have units, so we don't know if it's 44 yards, miles, inches, centimeters, but it's 44. All right, now we need the area. So we're going to chop it up into smaller rectangles. And so far, every time I've done the big long rectangle here with the little ones in the corners. I'll do it the other way this time. This time I'm going to cut it here and here and here. I'm going to find the area of each of those rectangles and add them together. All right, here goes. We just have to be careful to make sure we're using the appropriate numbers. So let's see, this one is 8 by 4. So 8 times 4, that has an area of 32. This one, wow, there's this 12 down here, but that's not it. It's the 4 is how wide this is. And then how tall this one is. Let's see. Anybody want to tell me how tall that one is? How tall is that one? Mariana, it's you. Ashley, excellent. Miranda, very good. That's awesome. You're all totally dialed in. Nicole, too. And it's 5, and it's because it would be 7 from here to there, and we need to subtract 2. Leaving us at that point would be 5, and that's exactly what we're looking at. And so 4 times 5, this would have an area of 20. Then finally, we have this rectangle over here on the right that is 4 by 7. That's 4 by 7, so that has an area of 28. To get the area of the whole figure, we'll add those together. 32 plus 20 plus 28 is 80. So our area would be 80. Very good, Nicole. Thank you. And if you had done it by cutting this up into a rectangle here and 2 rectangles here, you'd get the same thing. All right. Now I'm going to try to throw you a little bit of a curveball in this next one, but I'm going to work on it so that you see it done. The curveball is we haven't had any diagonal lines yet. Now we've got one. What in the world are we going to do with this diagonal line? If I wanted to find the perimeter of this, it'll be 4 plus, I don't know, plus 3 plus 12 plus 9. But that I don't know is a little bit weird. I'm not going to be able to do any addition and subtraction to find out this diagonal line. Instead, when we have a diagonal line like that and we need to know how long it is, because we have to find the perimeter, we're going to kind of look at what we would do to find the area first. If I wanted to find the area of this, which I'd be asked to do, I would, well, I'm going to cut this into a rectangle here and then another rectangle here. And when I do that, what jumps out at me is that I just made a right triangle. I just made a right triangle. How about that? Okay, I've got this right triangle in there. And then let's see if I can figure out the side lengths of this right triangle. So as I look at the horizontal parts of this shape, it's 12 all the way across. This is 4, so how long is this leg of my right triangle? How long would that one be? Excellent. Kevin, Jenny, Jessica, you're all right there with me. I love it. Thank you very much. The more people type it in, the better. It's like looking around the room and seeing a whole bunch of nodding heads. It's perfect. So this has a length of 8. And then how about this side length over here? How long would it be? Vertical line. So we're looking at the vertical lines in our shape. How long would this leg be? 6. It's you. Jenny, Jessica, Ashley, awesome. Thank you very much. That has a length of 6. And now, if I remember back to Tuesday, when I have a right triangle and I know 2 legs, I can find the length of the hypotenuse by using Pythagorean theorem. And that's exactly what we're going to do here. Now that I know those 2 side lengths are 6 and 8, I can use Pythagorean theorem to find that missing side length that I don't know, which is the hypotenuse. So I'll have leg squared plus leg squared is hypotenuse squared. Yeah, let's see. 6 squared will be 36. 8 squared will be 64, and that's hypotenuse squared. Add those up, and that's 100 is my hypotenuse squared. One more step to go. And she was a little bit ahead of me, and that's awesome. I'm going to take the square root over here to get those to cancel to find out that my hypotenuse is square root of 100, which is 10. So I just found out that that side length that I didn't know, that diagonal line that I wasn't going to be able to get with addition and subtraction, I was able to get it by creating a right triangle and using Pythagorean theorem to find out that that's 10. Now I can find the perimeter of my figure. You want to be a little bit careful here. Remember, perimeter is what we get when we walk around the outside of the figure. So even though we found 6 and we found 8, they're not a part of the perimeter. So we're not going to use those there. The perimeter is just going to be the outside of the shape. So that'll be 4 plus 10 plus 3 plus 12 plus 9. Just those 5 numbers added together. So 4 plus 10 plus 3 plus 12 plus 9. We'll add those up and get the perimeter. 4 plus 10 plus 3 plus 12 plus 9 of 38. So the perimeter of this particular shape is 38. Let me know if you have questions on that. Up next, we're going to find the area of this figure. All right, let's do it. So for the area of this figure, what I have here now is I've got a rectangle, and I've got a rectangle just like we had in the other shapes we've looked at. Now I also have this triangle that I'll need the area of. So I'll need to remember that the area of a triangle is 1/2 times the base times the height. I'll have to keep that in mind. We'll go ahead and do that one first. We'll find the area of that triangle first. And in this triangle, my base down here at the bottom, that's this 8. And my height, the vertical distance there on that leg, is 6. So the area of this triangle is going to be, the area of the triangle is 1/2 times the base, which is 8, times the height, which is 6. We'll multiply those together. 1/2, remember that's 1 divided by 2. So on my calculator, when I do that 1 divided by 2, I'm going to have 0.5 times 8 times 6. So now I can do the multiplying. Times 8 times 6, and I get 24 for the area of the triangle. There's a lot of work to do here. So it'd be really easy to go, okay, area is 24, moving on. Wait a minute, we don't want to forget about the area of these 2 rectangles. So let's make sure we do those too. This rectangle over here, let's see, this has a length of 6, this has a length of 4, so the area of that rectangle is 24. And then down here, let's see, this length, there's that 8 sitting right there begging me to use it, but the length is the whole distance. It's that 12. And then the height is that 3, so 12 times 3 will be 36. We want to make sure we're careful to use only the numbers we're looking for here. 36 is the area of that rectangle, 24 is the area of that rectangle, and 24 is the area of that triangle. And so the total area is going to be 24 plus 24 plus 36. Which is 84. So the area of this shape will be 84. I'm going to talk back through this one because there's a lot going on there. Okay, so we're given this shape and it's got this diagonal line in it. And you know, when it was all horizontal and vertical, I could do some addition and subtraction to find these missing side lengths. That was okay, I was comfortable. Now we've got this new diagonal line here that's a whole new thing. When we have a diagonal line, what we're going to do is we're going to create a right triangle inside there so that we can use Pythagorean theorem to find the length of that diagonal line. Once I've got the length of that diagonal line, perimeter is easy enough. I just add up all the sides that are on the outside of the figure. Be careful. We don't want to include sides that are on the inside of the figure in the perimeter. Then we go to find the area. And rectangles, well, that's normal. That's what we've been doing. We just have to be careful to use the appropriate length and the appropriate width. Here, that 12 times 3 made 36. And here, the 4 times the 6 made 24. Also, we had to find the area of a triangle in this one. Remember the area, the formula for the area of a triangle, and then we'll use that to find the area of the triangle. And then we add up the triangle and the two rectangles to get the area of the whole shape. There's a lot going on there. There's a lot to keep track of. I don't think any individual step by itself is that difficult, but there's a lot to do and a lot to keep track of. So you've got to be patient with yourself as you go through these. Does anybody have questions on that before I have you try one that has something new in it? Okay, here goes. Here's a composite figure, and we're going to find the perimeter and area of this. I am going to give you a significant hint, I think. What we have here is a rectangle, and then in addition to that rectangle, we have half of a circle on that side and half of a circle on that side. And because we know this side length here, we know the diameter of the circle. And if we know the diameter, we can find the radius. With all that in mind, I'm going to give you a chance to find the perimeter and area of this figure. I think it's a pretty challenging question, but I think it's one you can do. So we want the perimeter and the area of this figure. You can see in the answer choices that the ones that have decimals have been rounded to the nearest hundredth. So if you get decimals, you can round to the nearest hundredth when you look for your answer choice there. I'll give you time on this. And if your answer is none of those, you just make sure you pick the one that's closest to yours. That'll let me know that you had enough time to solve it. Like I mentioned before, I don't think this one's easy, but I do think you can do it. So we're looking for the perimeter, which means we need all the side lengths. That thing in the middle is a rectangle. So the 13 at the bottom, there's going to be a 13 at the top. And then we also need the area of the whole thing, which is a rectangle and two half circles. Oh, that's okay, Nicole. I don't know if you can see the poll or not. If you can't participate in the poll, that's all right. Essentially, we're finding the perimeter and the area of that figure, and it's a rectangle with a half circle on the left side and a half circle on the right side. We don't have to be in a hurry on this. We only have a couple of more things that we need to talk about today, so I can give you plenty of time to work on this one. You have to remember the formula for the area of the circle from earlier today and the formula for the circumference of a circle from earlier today. Those both play a role in this problem. Let's go another 30 seconds on this, and if you want more time, you can let me know. Okay, let's see where we are on this one. Okay, definitely strong agreement. Not as many answers as I would have hoped for, but definitely strong agreement, which is a good thing. So I'm a little bit torn on how to know where you are on this one, but we'll do it together. We'll be a little patient and careful here. So the first thing we're asked to find is the perimeter, which is going to be, I need to add up all the sides on the outside of the figure. And since this is a 13 down there, and I know it's a rectangle, it's also going to be a 13 up there. Since it's an 8 over here, I know it's going to be an 8 over here. I still don't have enough to find the perimeter, though, because I'm going to need to know this piece and this piece to find the perimeter. So let's see. Over here, I have this half of a circle, and the radius is 4. Radius is half the diameter. And so since the diameter is 8, then I know for sure that the radius is 4. So what I need to do is find the circumference of a circle with radius equal to 4. Well, we did that before. Y'all did great with that poll. So let's see. Circumference is 2 times pi times the radius. So the circumference would be 2 times pi times the radius. I'll multiply all those together. 2 times 3.14 times 4 is 25.12. Have to be a little bit careful though. The circumference is all the way around the circle. So that would be, if I had the whole circle here, the circumference would be 25.12. But I don't have the whole circle. I only have half of it. So I'll need to cut this in half. 25.12 divided by 2 is 12.56. And so what I just found out is that the length of this curve right here, we might call it an arc if we were being very specific, but the length of that curve is 12.56. Now, we could go through the same process on the other side, and we could say, okay, if the diameter is 8, then the radius is 4. if I find the circumference of that whole circle, it's going to be 25.12. And so if I want the distance around half of that circle, that's going to be 12.56. It's going to be the same as the other side. Now I have all the information I need to find the perimeter of this figure. It's going to be 13 plus 12.56 plus 13 plus 12.56. Got to be a little careful. We don't want to include any of this stuff that's on the inside, because when we're talking about the perimeter, we're just talking about the outside edges. So I can imagine myself here walking around this shape. 13 plus 12.56 plus 13 plus 12.56. So we'll add those up to get our perimeter. Let's see. 13 plus 12.56 plus 13 plus 12.56, 51.12. That's our perimeter. If you have any questions about where any of these numbers came from, or how'd you know to do that, or why'd you cut it in half, or anything like that, please ask them. Don't sit there confused. If everybody knew how to do everything, they wouldn't need to come to class. So I encourage you to ask questions when you have them. All right, so now let's look at the area of this. Well, one part's going to be nice and easy. The area of this rectangle in the middle, that's just going to be 13 times 8. That's going to be 104. So that much we get pretty easy. It's just the area of a rectangle, length times width. Okay, now I've got this half of a circle over here that I need the area of. Okay, well, I know what the radius is. And as far as a circle is concerned, the area of a circle is pi times the radius squared. So when I'm talking about this right here, and for right now, I'm just going to imagine there's an entire circle there. And the area is going to be pi r squared. So let's see, that's 3.14 times the radius, which is 4 squared. Got to remember order of operations. Do the squaring first and the multiplying after. So that'll be 3.14 times 16, which is 50.24. Now that 50.24 is, if I had an entire circle, that would be the area of it. But I don't have an entire circle. I only have half. So what I need to do then, same thing I did with the circumference, I need to cut that in half to find out that the area of just that piece over there is 25.12. So the area that's inside there is 25.12. Now I need to go to the other side over here, and well, here I've got a circle with a radius of 4. I would like the area, I can find the area of the whole thing, and then I need to cut it in half. Well, you know, it's exactly the same as the one on the other side. So the area of that is also going to be 25.12. And so now when I want the area of this whole shape, it's going to be 25.12 for the half circle on the left, plus 104 for the rectangle in the middle, plus 25.12 for the half circle on the right. And we'll add all that together and end up with 154.24. I think that's a pretty cool problem because we get to work with circles and composite figures all rolled into one. It's everything we did all day today. We found circumference, we found area, and we worked on a composite figure. So I think it's a cool question because of that. Are there any questions on that? Before we do a couple more, this next one's a little bit different. I'm gonna have you help me decide what to do. Okay. Find the area of the shaded region in the figure below. What that means is, what's the area of the blue part? So I don't want the area of the whole rectangle. I just want the area, oh, wrong color. I just want the area of this blue part right here. This is one of those standard algebra 2 type questions where a walkway is built around a pool. And so you can imagine this is a walkway built around a pool. We want the area of just the walkway. How am I going to find it? I don't need you to tell me what the number is. I just want you to tell me what to do to find the area of that blue part, because I don't have a formula for that. To find the area of something that's hollow, I don't have it. So how am I going to find the area of the blue part? I know that some of you are more likely well, I'd say be vocal, except you're typing. Some of you are more likely to type and enter answers than others, and that's perfectly fine. Some people are a little more reserved, and that's okay. I'd love it for you to come out of that shell, and if you know how we're going to find the area of the blue part, to tell me, but it's okay. There are some people that are more comfortable typing and posting answers out there, and that's great. And if you're one of those, don't feel like you're the only one that ever posts. It's fine. Go ahead, post. And so if you have an idea, and even if it's not correct, it's okay, on how we would figure out the area of the blue part, just let me know. As with everything else we work on, nobody expects you to see the answer right away. Instead, oh, that's interesting. That's an interesting angle, Jessica. I like it. You're very close, Nicole. Nicole's got something there, and Jessica's got something there too. Both of those, Nicole's close, and Jessica's is interesting. I hadn't had a student suggest that before, but it's pretty clever. I've got a couple more coming in, so we'll wait and see on those, and then we'll kind of look at them all. Kevin says, subtract the area of the small one from overall. That is sort of the most common approach, and I think that's where Nicole was headed. She just had subtract instead of divide, but I mean, she had divide instead of subtract, but that was the idea Nicole was right there next to. Jessica's idea is interesting. We could make a rectangle here, and we could find those side lengths, because if it's 9 all the way and this much is 7, then that's got to be 1. And then we could make a rectangle here, make a rectangle here, make a rectangle here, and find those 4 areas and add them up. That would absolutely work, and I think it's terrific, Jessica. More common than that, but your way's great, is what Kevin suggested that I think Nicole was after, is we can find the area of this whole thing. Fighting with my pen, sorry. Find the area of this whole thing, which is 9 times 5. So the area of this entire thing would be 45. And then after that, find the area of this rectangle that's on the inside, which is 7 times 3. We'll call it the area of the small part. That's 7 times 3, or 21. And if the entire shape has an area of 45, and I subtract the area of the inside, what I'm left with is just the area of the shaded blue part. Oops. So if the area of the small is 21, we can subtract and have 45 minus 21. The area of the shaded part is 24. Let me know if you have any questions about that. Hopefully it made sense, and great job, Jessica, Nicole, and Kevin for coming up with a suggestion there. That's terrific. All right, I have one more that I want you to try. And it's a partial figure, that Pac-Man shape right there. What I want you to do, keep in mind what we did when we were finding the area of these semicircles here. It was half of a circle. With that in mind, what I want you to do is find the area of that Pac-Man shape shown in that figure. We can see it as a radius of 4, what's the area? I'm going to set up a poll for this one and have you tell me. So what's the area of that figure, that Pac-Man shape right there? And this was a little bit of an experiment on my part because you may know what you want to do and not know the mechanics of how to get there. And that I would understand completely. So, so if that's where you are, if you're like, well, I know what I want my answer to be, but I don't know how to get there, that's perfectly fine. We are going to talk about it here in just a minute. But the idea is that we don't have an entire circle. I think that's it, Nicole. That is the thing, right? And that's what we'll talk about in just a minute. And it could be that you know, that this might be one that's not that great for a poll because of the process to get there. I think a lot of people know what they're trying to get to here, but maybe the arithmetic that's involved, they're just not sure. And that would be a good reason for us to talk about. Not 16, but you definitely could use subtraction here if you wanted to. Let's go another 15 seconds and then we'll talk about it. Because I'm feeling like the calculation here, the philosophy you might be good with, but the calculation you might not. And so I want to make sure that we solidify that before we finish up. So let's go ahead and take a look. Okay, we do have some agreement here, but not that many answers because I think the philosophy you're probably good with. I'll talk through this and you let me know if you have any questions about what we do. What we've got here is we have 3/4 of a circle. We don't have an entire circle. We have 3/4 of it, right? Because if I saw the whole circle and I chopped it into 4 pieces, there's 1, 2, 3, 4 pieces. I have 3/4 of an entire circle. And so what I want here is I'm going to pretend it's an entire circle, find the area, and then what I need is 3/4 of that. So let's pretend that it's an entire circle with a radius of 4. Our area is going to be pi r squared. So the area is pi times the radius squared. So that's 3.14 times 16. 3.14 times 16 is 50.24. So if I had an entire circle here, the area would be 50.24. But I don't have that. Instead, what I have is 3/4 of an entire circle. Of is a word that clues us in that we should multiply. So what we want to do here is we want to do 3/4 times 50.24. We want 3/4 of the area of the whole circle. So 3/4 of the area of the whole circle. And that's how we're going to find the area of this partial figure. 3/4, that's a fraction. So that's telling us to go ahead and divide 3 divided by 4. So we'll do that, 3 divided by 4, and I get 0.75. Then I need to multiply by 50.24. And so we'll do that multiplication and end up with 37.68. And that was the most common answer here, which is good, but I think a lot of you knew you were looking for 3/4 of the area of this entire circle, but didn't exactly know how to get there. And this is how we'll do it. To find 3/4 of the area of the circle, we're going to do 3/4 times the area of the circle. And the way we'll do that is 3/4, that's really just 3 divided by 4 to get this 0.75. Then we can multiply by the whole circle to have the area of 3/4 of the circle.